Hello and welcome to Dr. T's Math. In this video I'm going to demonstrate how to graph rational functions, find holes, vertical asymptotes, and horizontal asymptotes using the TI-84 emulator. Say we got a rational function here which is basically just a fraction with stuff on top and stuff on the bottom that has letters and numbers and addition and subtraction signs. Binomials and trinomials on the top and bottom. These are still fractions, just like 3/4 or 1/5 or something like that. We've got a numerator, we've got a denominator. Now if you're working these by hand, the first thing you got to do is try to factor out common factors from the top and bottom, see if you have any removable discontinuities. So let's take out an x on top and we get x minus 4. And on the bottom you got a factor. This is a pretty simple one. We got minus minus outside parentheses, so we're going to have a plus minus. We got a leading coefficient of 1, and so we're looking at factors of -8. That sum to -2, and of course we've got minus 4 plus 2. And so then that means this is a common factor on top and bottom, which means that we've got a whole or removable discontinuity at x equals 4, so x equals 4 there. And then we've got to deal with our vertical asymptote rules and our horizontal asymptote rules. Vertical asymptote is where the denominator equals 0, so that number is excluded from the domain. And then in this case, it's going to be here. X plus 2 is equal to 0, and so x is equal to -2. And so we've got a removable discontinuity here at x equals 4, and then we've got a vertical asymptote here. Last thing we've got to think about is the horizontal asymptotes. These come in a few different types, a couple different types, I should say. If the degree of the numerator is greater than the degree of the denominator, then we can just do synthetic division and there's not going to be a denominator, so there are none. In that case, if the degree of the numerator is equal to the degree of the denominator, then it's at y equals 0. And if the degree of the numerator is less than the degree of the denominator, then it's the ratio of leading coefficients. Ratio of leading coefficients. So that's the by hand method there, or the old-fashioned way. Let's look at the calculator here. We're going to go y equals, that's above second. Clear these out. And then our two functions were x squared minus 4x, then in parentheses. Make sure you get parentheses on these TI calculators. They're sticklers for syntax, and then that's going to be divided by x squared. Arrow right, minus 2x, minus 8 in parentheses. And let's see what happens when we graph. This is a much better resolution graph than you'll get in a regular TI calculator, except for the Nspire, one of the newer versions. And so, we could have also put the y equals in factored form, or we could have done it in, let's do alpha y equals, displays a fraction. Let's put all this as a fraction. We've got x, and then our factored form was x minus 4. And then we've got x plus 2, and x minus 4. Both of these are the same thing. We press graph, it's just going to be overlapping. I'm stuck in alpha mode. There we go. Same thing, right? And so what does that mean? Well, let's go to the zoom window. Back here, zoom window, and the home screen is window there. And we're going to go back down to Xres. Where's my Xres? On this version of the calculator, we don't have Xres. So, on your calculator, it'll say Xres, and then you're going to press 2 on the X resolution, meaning that it's going to indicate the vertical asymptote with a vertical line. Unfortunately, on this one, I don't have that option. So that's a slight difference between the emulator and the real thing. And so you would see a vertical line right there at x equals 2, where there's a clear asymptote. But let's continue on. I'm going to go second graph. I'm going to X out of here. Go second graph, and it's going to show a table. And so this is our table of values, right? Here's x equals 4, y equal, these are both going to be equal, y1 and y2. Our two graphs are just the factor form and the expanded form. So start at -4, at 2, and then if we scroll up to 2, complex infinity, that's our vertical asymptote right there, x equals -2. Go back to the graph. We can see right there at x equals -2, we've got an asymptote. Go back to the table. So here we are at -1, -1, fair enough, 0, 0, and then on to 4, indeterminate. Indeterminate is going to be that removable discontinuity. And so if we go back to the graph, then we can press second trace, second trace. Oh, do I not have trace on this one? Well, another small difference. I've got trace on here, and I'm just going to trace over to x equals 4, and we should show a hole right there at 4, and it skips right over it. Yeah, so on your calculator, so this is a slight difference between the emulator. On your calculator, there will pop up a small x equals down at the bottom of the screen, y equals, and you can type in x equals 4. We can see that in the table here, where x equals 4. It's indeterminate. That's the removable discontinuity. On yours, it might show error when you press second graph showing this table. Instead of indeterminate, you'll see error. And so finally, let's look at the horizontal asymptote. And in order to find the horizontal asymptote, we're just going to type in something real high and scroll way down, something fairly high on the x. And we can see the decimals there just getting closer and closer to 1, closer and closer to 1. And so what that means is, back here on this screen, so we've confirmed that when the degree of the numerator equals the degree of the denominator, then y doesn't equal 0. When the degree of the numerator is equal to the degree of the denominator, we have a ratio of leading coefficients. So see, we just confirmed something there on the graphing calculator. When n is less than d, then we have y equals 0. Back to the graph. Now let's just put that to the test here. That what we just confirmed on the other slide. Instead of x squared divided by x squared divided by x squared, let's say x squared divided by x minus 4. And we'll see another removable discontinuity there. No, let's do x minus 2. So we won't see any, we won't have any horizontal asymptotes there. Oh, because the degree of the numerator was greater than the degree of the denominator. So here, let's take out that squared and type in x squared here. And see what we got. Right? And then, so we can see the horizontal asymptote as we scroll over is definitely y equals 0. So going back to the rules on horizontal asymptotes, here we are. And just confirmed with the calculator that if the degree of the numerator is greater than the degree of the denominator, we had a slant asymptote there in that quick example. There are no horizontal asymptotes. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. And if the horizontal asymptote is the ratio of leading coefficients, that means that n is equal to d, or the degree of the numerator is equal to the degree of the denominator. Okay, this has been Dr. T's Math. Thanks for watching.